gentlemen. So today we're going to talk about solving simple inequalities, 5.1 and 5.2. And because we're starting a new chapter, you should have a new printout that's going to be glued into your notebook for all of our chapter 5 assignments. Check on Teams and find the PDF if you need to print it at home. So for 5.1 and 2, the skills we're working on are similar skills that we've been working on all year, but this time we're adding in the idea of inequalities. So for ACED1, we're going to create equations and today inequalities in one variable and use them to solve problems. And we're also going to solve linear equations and today inequalities in one variable, including equations with coefficients represented by letters. So to do that, we have a few vocab terms to define. The first one is the idea of an inequality. So this is not the same way you use the word inequality when you're talking about it in social studies or history class. An inequality in math is an open sentence that uses the symbols less than, greater than, less than or equal to, or greater than or equal to compare two quantities. And so as I was reading those symbols, I used the words that we would use to describe them. In your notes, you can have just the symbols because I expect by this point in your mathematical careers that you know what each of those symbols means. When we're describing things in words, we might use some of the other words that are on the thing here. That'll be more important when we move on into our word problems coming up. The other idea that we're throwing in today is this set builder notation. So set builder notation is a concise way of writing a solution set. The example given is that t, when t is less than 17, represents all numbers t such that t is less than 17. So it's just a slightly different way of writing our answers. The last vocab term for today is this idea of the multiplication and division properties of inequalities. Typically, when we're dealing with inequalities, and we'll talk about this on the next slide here, we use our equation solving skills. We leave everything the same. But when we're solving inequalities, if we are multiplying or dividing by a positive number, everything stays the same. It's just this last piece where if we're multiplying or dividing by a negative number, the inequality symbol switches direction. So it goes from this way to this way. Or it goes from this way with the line under it to this way with the line under it. We'll go through some examples so you'll see why this happens. But this is a big piece. You just got to remember it. So, steps to write down in your notebook. The first thing we're going to do is we're going to treat the inequality as an equation and follow our equation solving skills to isolate the variable. So what this looks like is for our addition and subtraction, whether it's positive or negative, we follow equation solving steps. For multiplication and division, again, we follow equation solving steps if it's a positive number that we're multiplying or dividing both sides of the equation by. But if it's a negative number, we need to flip the sign. It changes direction. Then we're going to graph our solution. Most of our problems today ask us to graph the solution. If we are using just less than or greater than, we use an open circle. And what that tells me is that x is every number greater than -1, but it does not include -1. When I have that or equals to piece here, that little line on the bottom tells me that x is greater than or equal to -1. So I need to fill in that dot to show that -1 is a possible solution. So now let's practice with our inequalities here. The first one, I have k plus 24 is greater than 5. Well, I'm going to treat it like an equation. I can still build a wall like we did way back at the beginning of the year. I'm going to take away 24 from both sides to get my variable by itself. Well, I didn't do anything with multiplying or dividing by a negative number, so my symbol stays the same. And my final answer is that k is greater than -19. To graph my solution, I'm going to build a short number line, and I'm going to center it at -19, and I'm going to put at least one number larger and one number smaller. Because my symbol is just the alligator mouth with no line under it, I have an open circle. Well, with my open circle now I need to figure out, I want k values that are greater than -19. -18 is bigger than -19, so I would shade this side of my inequality. Well, let's practice this again. This one is a homework problem from page 295, number 21. I have 6p is less than or equal to 96. Well, in this one here, again, using my equation solving skills to get p by itself, I need to divide both sides by 6. if I'm thinking about my multiplication and division rules of inequalities, this is a positive number, so nothing changes. I keep my symbol facing the same direction, and I get P is less than or equal to 96 divided by 6. Grab a calculator here, so my brain is dead. Let's see. We have 96 divided by 6. We have 16. So P is less than or equal to 16. Now again, to graph this on a number line, I'm going to build a short number line, and I'm going to center it at the value I have. And I want to have one value larger and one value smaller. That's a 17. There we go. And I'm going to center it at 16. Well, in this case, I have that or equals 2 piece, so I need to fill in my bubble. I have a closed circle at 16. I want to think about possible values, and so I can use it. If I plug in 17, well, that's false. 17 is not less than 16. So I know that it's going to face the other direction. P is all values that are smaller than 16. Let's make it a little more challenging. A couple more practice problems here. In this one, again, to isolate my variable, to get f by itself, I need to multiply both sides by a -6. Thinking about my rules here, I'm multiplying by a negative number, so my inequality symbol is going to change directions. F is all by itself, but now the direction of my inequality is the opposite, and I get a -72 times a -6, which gives me a positive 432. Graph it on a number line. Again, I'm going to center it. I have 432. 433 is one larger. 431 is one smaller. Because my symbol does not have that or equals 2 piece, I'm going to leave it as an open circle. And now I need to figure out, well, my letter is on the other side. If I plug in an example, if I plug in 431, is it a true statement? Is 432 bigger than 431? Yes. So I would shade in this side. The idea here is that the inequality, we're going to go back to kindergarten for a second here. The inequality is an alligator and it wants to eat the most cookies. So you always want the open part of your inequality symbol. It faces the larger number. The smaller part, the closed part of your inequality symbol, faces the smaller value. Now let's do a two-step problem here. I want to get x by itself, so I'm going to use my equation solving skills. Take away 7 from both sides, and I get 12. My inequality symbol has not changed. And then I need to divide to get x by itself. But when I divide, I get 6 is less than or equal to x. Again, because it was a positive number, there's nothing I need to do. I only worry about it when it's a negative number. So I'll build my simple number line here. In this case, my circle will be closed. I have that or equals 2 piece. And I need to test. Well, if 5 is 5 bigger than 6? No, 7 is bigger than 6. So I choose the side that's greater and have my symbol shaded. Another problem here to practice with, and this one's out of the homework. It's from page 288, number 34. We're going to define a variable, write an inequality, and solve each problem, then interpret the solution. So Keisha is babysitting at $8 per hour to earn money for a car. So far, she has saved $1,300. The car that Keisha wants to buy costs at least $5,440. How much money does Keisha still need to earn to buy the car? So we want to figure out how much money she needs to earn. So the first thing I'm going to do is I need to define a variable. Well, I'm thinking about Keisha earning money from babysitting, so I'm going to let x equal hours that she works. A little messy on my fingers today. I want to make x the number of hours that she worked. So I know that she has $1,300 plus she can earn $8 per the number of hours that she works. So this is how much money she can earn. Well, the car that she wants to buy costs at least $54.40. So it might be, the at least tells me it could be that she needs exactly that amount of money, or it could be that she needs even more than that. So I need to have the amount of money that she has be greater than or equal to $5,440. So I define my variable, x is the number of hours that she's babysitting. I wrote my inequality, and now I need to solve it. So if I solve this here, first thing I need to do is take away 1,300 from both sides. When I do that, I get 8x is greater than or equal to 5,440 minus 1,300, which gives me 4,140. Well, when I get x all by itself, I divide both sides by 8, and I get 517.5. So I know that she needs to work at least this many hours. My solution is there. To interpret that, that tells me she needs to work, Keisha, E-I-S-H-A, must work at least 517.5 hours. I completed all parts of this multiple step problem here. Now technically it just asks me how much money she needs to earn, so I could have written this out without that multiplied by 8. I think that the problem was written incorrectly. The better interpretation is how many hours should she work? She needs to work at least 517. It's a long time. Cars are expensive. So your homework tonight is really two separate homework tasks. The first one is from page 288. This time it's 5 through 30 multiples of 5, not 3. I cut it down. Multiples of 5 plus 34 and 47 through 50. And then on page 295, again, it's back to multiples of 3 and a couple extras sprinkled in there. I split it up into two separate homework assignments, so you should do one tonight and you can finish the other one up tomorrow. But make sure you submit both forms. I'll have them out as separate activities on Teams. Thanks, guys. Tomorrow we will, or the next learning day, we will continue with this, and we're going to talk a little bit more about why we have to flip the sign when we have a negative multiplication or division. Good luck.